My name is Dr. Peter Wampler, and I'm a geology professor at Grand Valley State University. And I'm going to talk to you a little bit about fracking. A bit about my background: I worked in the mining industry for several years and worked on drilling rigs, kind of familiar with that aspect of geology. And so I'm going to share with you what I know about the geology of hydraulic fracturing and also a little bit about the process that they use to recover oil through hydraulic fracturing. This fracking basically is referred to as unconventional gas recovery, because you're not just collecting gas that's already out of the rock, it's being generated by your process of fracking. You're actually fracturing the rock, propping it open, and that's what allows you to recover the gas. So the shale at the surface is typically brittle and fractured, and all the gas has already been released from most of the shale at the surface. It's only when you get deep into the ground that the shale still retains the gas. And that's why the fracking is necessary to get that gas out, because the gas is bound up in very, very small pores in the shale. In order to get it out, you have to fracture it, prop it open, and allow that gas to seep out. Essentially, what the fracturing does is it increases the permeability of the shale, so you can recover the gas from the shale. And it's also, that fracturing process is sort of enhanced by what are called proppants. And it has the root word prop, which you can think of propping a door open. Well, essentially, you're propping open the fractures after you create them with hydraulic pressure. So you create hydraulic pressure, and then you use what is called a proppant, and this is what a proppant looks like. Essentially, they're much smaller than this in reality. They're very small things the size of very small sand grains, and those are injected with the liquid or gas, or liquids basically in hydraulic fracturing, and they prop open the fractures so that they don't close again. And that allows the gas to slowly seep out and reach the drill rig and reach the pipes that recover the gas. There's also chemicals that are injected, and that's one of the controversial aspects of fracking, because the chemicals that are used, there's a wide variety of them used, and they vary in their toxicity, they vary in what they use, everything from what would be like a antifreeze in your car to all kinds of different types of chemicals are used for different purposes in the fracking process. And just to give you an example of what the shale looks like before it, when it's in the ground, this is sort of what shale looks like. And you can notice it's not very fractured. This particular one's not fractured. But in the image that I've shown here, this is actually shale at the surface. At the surface, shale is usually quite fractured. It falls apart, very brittle. But at depth, thousands of feet in the earth, it's a very hard substance, very low permeability. That's why it's necessary to fracture it and to prop open those fractures to get the gas out. Okay, so why is fracking booming? Why is it a big deal now? Why is everyone talking about it? Because largely two reasons, three reasons. Two are technological, one is more of a sort of a resource reason. So around the beginning of the 2000s or so, there's a technique called horizontal drilling or directional drilling that was perfected. Basically, this means you can steer the drilling bit. You can actually steer it like a car. You can take it down vertically and you can steer it horizontally, or you can steer it anywhere you want pretty much. In order to do this, you have to do two things. You have to be able to drill directionally, and you have to be able to know where you're drilling to, right? So the other advance that's happened is there's been an advance in technology of knowing where your bit is in the ground. So you have to know really accurately where that bit is traveling through the earth in order to hit the right spot, and you have to be able to drill there in the first place. So those two combined technologies have made it possible to really find the oil, find the shale-bearing oil, or the gas-bearing shales that have the oil in them, and then access them, fracture them, put the proppants in place, and then recover the gas. So where are these natural gas reserves that people talk about? There's large quantities of natural gas stored in the shale. Some of them crop out on the surface, but oftentimes they're thousands of feet below the surface. And that's where the fracturing really comes into play, because the stuff at the surface is already fractured and the gas has already been released. So the only place that the fracturing makes sense is deep in the earth, where you've got shale that hasn't been fractured and opened up to release the gas. So really where they're talking about doing this is places with deep shale, thousands of feet typically in the ground. And some of the big areas that people are looking at, one is called the Marcellus Shale. It lies underneath large parts of the kind of the eastern seaboard, Pennsylvania, that area, and underneath Michigan, the state we're in right now. Underneath that is that called the Atrum Shale, and that's also a very large potential for producing natural gas from fracking. But all scattered throughout the United States, there are these different shale units that are potentially fracturable, and they could recover natural gas. last numbers I saw, based on this new technology and based on the amount of shale that's out there, we have somewhere around 100-year plus supply of natural gas from fracking, which is quite a bit. That's the number of years available. So a lot of people are concerned about fracking, and they, we just drove through New York, and there were signs all over the place: "No fracking. We don't want fracking." So there's a lot of people concerned about it, and a lot of people want to understand it, and a lot of people just don't want to see it happen. And some of the issues that people bring up, a lot of people are concerned about earthquakes. So when you fracture the ground, they're concerned that would cause earthquakes, cause instability of the ground. Another big one is groundwater contamination. There's a lot of videos on the web of people's faucets, water coming out and burning. So there's this perception that fracking is going to pollute water, it's going to pollute your groundwater, it's going to pollute your drinking water. And so that's a big issue. And then whenever they fracture and recover this, and they put all this hydraulic materials into the ground, they also have to pull out material out of the ground. So they're pulling out water that has chemicals in it, things from the ground, and they have to get rid of that somewhere. And so there's a lot of concern about surface contamination of waters like rivers and streams where that water would go to. And then there's the bigger issue, I think, of just, if we use more of this shale-produced gas, are we just perpetuating this reliance on fossil fuel that we should just be getting rid of? And that's kind of, I think, a pervasive opinion for a lot of people. And I actually share that opinion, that there is a need to get off of fossil fuels for a lot of reasons. And so, this is kind of extending that dependence on the fossil fuels. So let's address those one at a time. So the earthquakes. Just recently, a study was released by the USGS that said basically there isn't a lot of evidence to say that fracking causes earthquakes, at least not ones that we can feel. Now, that does cause micro earthquakes, things that we would probably not even feel, and that are measurable by delicate devices or precise devices called seismographs. But typically, as far as I know, there's not been a documented, reasonably large earthquake that we actually could feel that's been caused by fracking. Now, that's not to say that it doesn't cause some shaking occasionally or cause something you might feel, but it's not a well-documented thing by any means. And I have not found a lot of issues related to that. Certainly can cause small earthquakes. Lots of small earthquakes are possible, but are those going to damage your house? Are those going to damage structures? I don't think so. I don't think that's going to occur. Another concern people have is that causing fracking is going to cause their house to collapse into a hole or something like that. Well, the whole idea of fracking is that you prop open a crack and then you leave it propped open, so you're actually increasing the space in the ground, you're not opening a space into which something could fall. So there's not a big issue with subsidence or causing houses to collapse or houses to be destroyed through subsidence. Not like you would see with like a coal mine where there's an opening in the ground and things actually could collapse into it. Okay, groundwater contamination. This is actually a potentially really big issue and one that's still in the process of being studied. It's one of those questions that needs a better answer, I think, not quite answered very well yet. And the reason for that is that the things that they use for this hydraulic fracturing, there's a whole variety of chemicals, most with names I can't pronounce. And those chemicals are not well understood. Their fate in the ground is not well understood. And where these would end up if you start using them in large quantities in the ground is not well understood. So I would consider that a question that needs a better answer before we really go whole hog into putting a lot of these into the ground. So, and some states are regulating these. Some states are actually putting in place rules about what chemicals you can use and what you can't use. But that's still in the process stage, I think, at this point. There's more to be learned there. Surface water contamination. This, again, is a big issue, I think, in some places. So a lot of times when you're doing this hydraulic fracturing, you're producing water that's in the ground, and that water is typically salty and other things, like sometimes arsenic, sometimes other things in it, that come out of the formation, that come out of the rock. And so that is a big issue. If you have to put that somewhere, right? You have to put that in a creek, you have to put it somewhere. So that's something they're still learning about too, about where you put that stuff, how you treat it, whether you can put it back in the ground again or not, and if that works. Okay, so to kind of sum up some of these concerns, earthquakes are an issue, but probably not a very big issue. Groundwater contamination is a potentially big issue and one we need to learn more about. And surface water contamination of waters is also a big issue and something we probably need to learn more about before we do a lot of this. So what can we do about it? How do we do this intelligently? How do we approach fracking instead of just maybe not doing it at all? How do we do it so we can do it right? I would say monitoring is huge. If I were to be in the position to decide about fracking, I would say nobody gets to put any wells in for fracking unless they have agreed to do a lot of monitoring of groundwater, surface water, chemically analyze the water. Accountability. Oil companies that are doing this need to be held accountable for things that they do. If they have spills or make mistakes, they need to own up to it, and make amends for those. And then reporting is huge, I think. There's been a lot of talk about companies needing proprietary mixtures of hydraulic fluids and things like that. And there needs to be openness, I think, in a lot of this. There needs to be open release of what they're using, what the chemicals are. If they want to maybe not say how much of each one they use or somehow hide their exact mix, I guess they could try and do that. But we need to know what they're putting in the ground, I think, as a society. We don't want them just putting things in the ground we don't know about, or at least somebody should know. And then I think more support for research and data collection, maybe through universities or whoever can do this. US Geological Survey could do more of this. Just kind of overall support to support more information would be useful. And so that's kind of my summary of what I know about fracking and what I've learned, through my experience as a geologist. And hopefully you've learned a little more about fracking too.